This is Steve Fowkes welcoming you to Part 2. We've just finished the falling dominoes illustration and now revert to a verbal summary of the Alzheimer's cascade. Then we will start a deeper exploration of the brain's metabolic uniquenesses and its special requirement for biological energy. Alzheimer's disease is caused by a loss of glutathione cycling. One of glutathione's roles is to detoxify mercury. If glutathione is always greater than the mercury burden, then the toxicity of mercury is kept low. Glutathione is also an antioxidant, which defends the cells against free radicals and oxidation. Oxidized glutathione does neither. Oxidation of glutathione causes release of bound mercury. Released mercury poisons sulfhydryl enzymes. Sulfhydryl enzymes are vital parts of several critical brain systems, including microtubule maintenance, the phosphorylation cycle, and the energy backup system. Sulfhydryl enzyme failure is a defining characteristic of Alzheimer's disease, and glutathione restoration reverses Alzheimer's disease. Why is the brain special? There are several things that we can point to as highlights to illustrate this point. Some aspects of metabolism are unique to the brain. The phosphorylation cycle, in which brain enzymes are phosphorylated and dephosphorylated every 90 seconds, it is a good example of this. Brain neurons also have a unique shape, involving very long and thin extensions, or branches, called axons and dendrites, which form the neural networks necessary for cognitive function. This requires a unique reliance upon a transport system, called microtubules, that move materials from the center nucleus of the cell down the axons and dendrites to the periphery of the neurons where the receptors for neurotransmitters are located. They also move materials back to the nucleus. These microtubules, if they were scaled to the size of a two-lane highway, would stretch from San Diego to Maine. We'll come back to microtubules later. The brain also has unique functions. Not only are the electrical signals of sensory systems and motor control systems processed by the brain, but many of the hormones of the body are sensed by the hypothalamus and regulated by the pituitary glands in the brain. These are intimately involved in health, aging, and lifespan. The brain is also isolated behind the blood-brain barrier, which selectively passes and rejects certain chemicals to make the brain work properly. These factors can make the brain less sensitive to certain adverse influences in the world, like alkaloid poisoning from plants that are trying to keep us from eating them, or infections that are fought by the immune system on the body side of the blood-brain barrier, or insulin resistance, which affects the GLUT4 glucose transporters of the body and not the GLUT1 transporters that are favored by the brain. These brain uniquenesses can also make the brain more sensitive to other influences, like excessive coagulation that impairs brain perfusion more than body organs, carbon monoxide poisoning, which also selectively damages consciousness more than body organs, heavy metal, especially mercury, which damage brain development to a much greater degree, and hypothyroidism, which directly undermines the energy that the brain disproportionately consumes. These sensitivities of the brain all cause impairment of energy utilization by the brain. Energy is the key. We will come back to this central point many times in the following presentation. The bottom line is that the special sensitivities and insensitivities of the brain mean that body pathologies are not necessarily associated with brain pathologies. There are many demented people who are otherwise quite robust, and there are conditions of extreme physical disability in which mental acuity is minimally affected. Even within the brain, sensitivities can be selective. In Parkinson's disease, the parts of the brain dealing with motor functions and motivational tone are selectively affected. Cognitive function may not be noticeably impaired at all. Energy. How does it work? Biological energy is what maintains the structure and function of the body systems against the forces of chaos. Chaos is not the secret spy organization that Maxwell Smart fought, but rather entropy, the principle of disorder defined by the second law of thermodynamics, which states that closed systems always run down, or that their high-quality energy dissipates into waste heat. Practical examples of entropy might be the wound clock that runs down, the perfume that starts out strong and weakens as you wear it, the battery in your cell phone that loses a bit of its stamina every time you recharge it, or the warmth in your house that you have to replace as it leaks out through walls and windows, or your car's motor that needs to be tuned every 10,000 miles and rebuilt every 100,000 miles. It is an actual law of physics that the universe is falling apart. Biological systems have to fight entropy to survive, and energy is the tool used to fight entropy and stay alive. Biological systems accomplish this feat by extracting energy from their external environments and using that energy to stabilize their internal environment. So, order, or anti-entropy within an organism, is obtained at the expense of much greater disorder or entropy in the external environment. In other words, we are borrowing energy and paying interest on that borrowing. This does not violate the second law of thermodynamics because biological systems are open systems. In essence, living systems pump entropy into the external environment in which they live. If they cannot do this, they die. The anti-entropy currency that living systems use is ATP, or adenosine triphosphate. ATP is also called the energy molecule because it drives the enzyme activity needed for life. There are variations on ATP called GTP, CTP, and creatine phosphate that can be produced from ATP and can convert back into ATP. GTP and creatine phosphate have a special role in the brain. Reducing power is also a form of energy that is tapped just before it would otherwise be converted into ATP. Reducing power is used to directly regenerate the antioxidant defense system more efficiently than ATP can accomplish. This also is of extreme utility to the brain. It is the efficiency of energy systems that enables advanced life forms, warm-blooded animals, central nervous systems, and consciousness. Biological energy systems come in two kinds: the anaerobic system, which is more primitive and supports only single-cell life, and the aerobic system, which supports multicell and larger life forms. The anaerobic system partially burns glucose and generates lactic acid, while the aerobic system fully burns glucose or fat all the way to carbon dioxide. The anaerobic system generates only 2 ATP per glucose partially burned, while the aerobic system generates 38 ATP from each glucose fully burned. 2 ATPs is enough to support life, but 38 ATPs is enough to support multicellular life, central nervous systems, and consciousness. Now is the time to start part 3.